Hello everyone, let's try to develop the model of the exercise 4-6 4-6 in the textbook. Let me introduce the problem first. So here, parts arrive at the single workstation system according to an exponential interval time distribution with mean of what 21.5 seconds. So we have arrival information about the arrival process of the part, right? It seems like the system actually is processing part, right? The first arrival is at time t. So initially we can generate, when we run the simulation model and at time t, we can generate the first arrival of the part, right? And upon arrival, the parts are initially processed, okay? And the processing time distribution is triangle distribution with the three parameters, 16, 19, 22 seconds. There are several easily identifiable visual characteristics that determine whether a part has a potential quality problem. Okay, there is a visual inspection, seems like, right? And this part, about 10%, are sent to the station where they undergo to the inspection. All right, and then the remaining part are considered good and are sent out of the system. So 90% of the other parts, right? 90% of the total parts will be sent out, right? To the will leave the system basically, right? And the inspection time distribution also is following the Weibull distribution. Oh, okay, 95 plus Weibull distribution with these two parameters and random variable in seconds. Okay, time unit is second. About 14 of these parts failed the inspection. Okay, so we have a defective items here, right? Part, and are sent to scrapped. Okay, scrap. And these parts that are passed inspection are classified as a good and are sent out of the system. All right, so this part didn't need to thorough inspection, but you know what they say about hindsight. Okay, got it. And run the simulation for, so here is a run setup condition, right? 10,000 seconds to observe the number of good parts that exit the system, the number of scrap parts, and the number of parts that receive the thorough inspection, animate your model. Uh, and the hint, we can use record module to count entities. So basically, we can use basic process modules, right? So basic process panel, and then there are multiple modules, right? Such as record module and then create module and so on. Yes, so before we develop the simulation model, let's draw the flow chart, okay? So how can you do that? Let me open the PowerPoint. All right, so here, what was it? So initially, we can start, right? We can start the process. So here, usually, if you remember the shape of the flow chart, oh, there is a flow chart option. So here, why? Right, start. Right, that's a start. So start. Well, part alive, and then end. Or part alive and part dispose. Right, according to the description of the issue, we can have these two, right? Part alive at the same workstation, so single workstation. So we can put what box workstation, right? And then arrow. Oops. And what else? Workstation. And then here, and triangular distribution, blah, blah, blah. And then there is a what? Inspection, right? 10%. 10% will go to undergo the thorough inspection. 10%, 10%. So, okay, insert another shape here. And then inspection, right? So increase the size of this one. And then definitely yes or no, right? Yes, yes, or no, no, yes, right? So let me just reduce the size of this one. Okay, another arrow from workstation to here, and 10% undergo inspection and remaining parts are considered good. So no inspection means good and sent out, so disposed, right? This part will leave the system. So insert the arrow. Let me use this one. All right. And what else? Inspection. So inspected part will be what? Inspect the remaining part. Consider the inspection time is here, and then about 14% of the failed inspection. So inspection. So we need to put the inspection then. Let me copy and paste this one. And inspection, right? And another arrow. So after the inspection, about 14% scrapped, right? About 14, I guess. I believe that we have scrapped here. Right, about this part failed the inspection, or fail, or scrap, right? Fail, scrap, fail, fail. Let me put fail. Fail, and no. Also we have yes. And what? Yes. And then good, and 14 are sent to the scrap. Scrap. Right? Scrap. And they also, and something like that, right? It's just slightly different from the simulation model, but according to the description, yes, we need to have this kind of the flow, right, of the part, right? Part will follow this kind of processes, right? So workstation at the beginning of the simulation, parts are live at the simulation, and then it will go to the workstation directly. Yeah, I think that. Yeah. And then inspection is here, right? And then 10% will go through the total inspection year, and then out of the about 14% will fail, right? Will fail. Fail? Yes, no. Anyway, yes, yeah, scrapped. That's much better. Scrapped? Yes. Oh, yes, scrapped. And then otherwise, yes, leave the system. Okay, this is how you draw the flow chart, and based on that, you can draw, actually, you are ready. So this is a conceptual model, so of the simulation model. So based on that, you are ready to actually develop the Arena model. So let's open the Arena software. All right. So whenever you read this kind of description, it's better to think about the entire process of the simulation model, or it's better to draw the conceptual model of the simulation. So basically, you can draw flow chart, right, to develop the conceptual model of the simulation. So initially, we have a live process of parts, right, and then we have a process module, right, for the to process parts, right, and then we have it seems like inspection module, right, inspection process as well, right. So mm, and then there should be the record module as well to collect the statistical data, and then I'm sorry, and then we can have a decide module as well to provide a to address the determination process, right? The determination process of in the simulation model. So right, so based on your understanding, you're hopefully you are ready to draw or develop the simulation model using Arena. Okay, I assume that you already draw the flow chart, okay, or simple flow chart of this problem. All right, so let me try to put some modules, okay, to develop the simulation model. Initially, we need to have what? Create a module to generate a part. So here, if you double click it, we can get the necessary information here, right? Exponential interlevel time. So basically, this is an interlevel distribution for the to address the interlevel time between parts, right? And 21.5 seconds. Got it? So if you go back to Arena, you can change the name of the uh, entity type. Let's say part, right? So we have a part arrival basically, and then in seconds, and parameter was what? Parameter was, let me go back to the problem, 21 seconds, 0.5, 21.5. So here 21.5 seconds, right? So now, and then first creation is time 0. Why? Because according to the problem, it said that right, first arrival of the part is at time t. That's why. So we are just implement the first line of the problem, right? What's the next? Upon arrival, the parts are initially processed. Although we don't know about the name of the process, but anyway, there is a process, right, for part. So we can put the process module in addition to create module. Oh, sorry, let me go back to the Arena. And then here, let me change the name of this create module. Part arrival. Right, and then after that, we have process module following certain distribution, right? If you double click it and you can open it, right? So here we have process module, and let's say is a workstation process. And here see delay release, right? We need to have a resource as well. Although it didn't mention about it, but we can assume that we have 1 unit of resource here. And then distribution, so processing time is triangular 16, 19, 22 seconds. So let me add the resource here, workstation. Okay, and then here triangular in seconds. Value added. I already forgot about the parameter. 16, 19, 22. And click OK, right? In second, okay, all right. And then let's go back to the problem here. There are several easily identifiable visual characteristics that determine whether a part has a potential quality problem. So it's a quality inspection, right? So inspection of the quality of the product, basically part. So these part, 10%, right? About 10% are sent to the station. So undergo thorough inspection. So we need to put what? Put decide module, right? So let me go back to the arena here and where, and then we need to find out the decide module under the decision panel. Here you can put the decide module, and we can call it as a what? Inspection decide, or you can change the name as well. So 10% will go through the thorough inspection. True, 10% here, and other 90% will be there, right? And then we need to make a connection between these two. And what else? Go back to the problem here, and these part, about 10%, determined after initial processing, are sent to a station where they undergo thorough inspection. So thorough inspection should be, right, should be modeled. So here, the inspection time, okay, following this 95 plus variable distribution. So inspection process. Let's create the inspection process then. So go back to the discrete processing panel, and then here we have a process module here, right? So, and then double click this one to change its name. What about, let's call it as a inspection process, and this is delay release. And resource will be what? Inspection. Okay, and then what's the time unit? Second. And then we need to put the expression, right? Because it's a what? It's a 95% variable distribution with 48.5, 4.04. Please, whenever you model it, modeling the simulation, please do not copy and paste the text. Okay, sometimes it create an error. That's why. All right, 48.5, 4.04, right? Variable distribution, right? So if you don't know the distribution, actual expression of this one, and then you can use the build expression here. Okay, and then there should be the there should be the random distribution actually symbol here. So if you put the variable, and then you can see this variable here. Okay, in other words, 95 plus what? With the variable parameter. So if you click the variable here, and then you can put the scale, right? Actually parameters. Was it? I already forgot about it. 48.4, and then 4.04, right? So that's it. Okay, and if you click OK, and then you can also have this expression. And there is, yeah. So if you don't know the expression of the certain distribution, yes, feel free to use this build expression. So in order to do that, you can make a right click button on this area so that you can see the pop-up menu here. So the name is a build expression, and double click it, or click it, yeah, click this name. Okay, we are done with the inspection process. And what else? We need to go back to the problem here, and then about 14% of this part failed inspection and are sent to scrap. So failed, right? 14 of parts, this part, are failed. Okay, so another decide module, right? After this one, go to the decision panel here, and then put the decide module, another decide module here, right? And if you double click it, and then we can, what should we say? Scrap decide. Yeah, you can use any name, okay, if you want it. Okay, scrap this side. Okay, 14. This one part will be scrapped. Okay, all right. And go back to the problem here. These parts are passed the inspection, are classified as good and are sent out the system. The part passed the inspection are classified as good. So other parts, right? Other go to the just other part will leave the system basically without any problem. So dispose model, go to the discrete processing and then put the dispose mode here. So dispose module for the scrapped part, and then another dispose module for the good part, right? And then make a connection as well from here to there, right? So we are almost done. Let's look at this one. Okay, run simulation for 10,000 seconds. So if you go to the run here, run menu, there is a setup. So run setup, and then replication parameter here, and we will run the simulation only for the one replication. And however, we have a time of the 10,000 seconds here. So that we can run the simulation for 10,000 seconds. Click OK. All right, and then we just changed the run setup, right? To observe the number of good parts exist system, the number of scrap parts, and the number of parts that receive the thorough inspection. So what does it mean? So we need to put LA3, right? 3 record module into that. So let's put the record module here. So number of parts went through the thorough inspection. So we can put the record module here. So under this input output panel, we have record module, and then you can put record module over here, and it will actually automatically the connection between these two are made, and then also as well as these two also another connection between these two modules is made, right? So this records what? This one will record the number of the part basically. So let's change the name of this first. Inspection, I'm sorry. Inspection part record, right? So, and then click add button and count, right? Count the number of what? Number of inspected part, right? So we can use this record module. Click OK. What about other record modules? So we can put another one here and another one there, right? So okay, here let's put another record module here, okay, and double click it to change the name of this record module. Scrapped part, right? We need to count the number of scrapped parts. I'm sorry, let's change the name of this one as well. Scrap part record, okay, and click add. Number of scrapped part. Click OK. All right. What else? Last one. And just be careful about another connection. We need to make another connection, right, between this record and then design module. So go to home and then connect here, and also so that we can have this one, right? We have connection here. Okay, so what's the name of this one? Let's say good part record. Okay. Add one counter number of good part. Click OK. All right. So save the file. Whenever you save the file, please save the file under the download or the other folder using only having the English name in the path. Model 4-66 exercise, actually. Exercise 4-6. Right? And run the simulation model, right? Once you save it, and then you can run the simulation model. And here initially is time 0, and click again, and then you can see the time here, right? You can speed up as well. Okay, simulation has no completed, and see the result. Click OK. So we can see the result basically. All right, so now you can see the statistic here. Inspection queue and the workstation queue, right? There is a half width as well. And what else? Let's go to the output information, and then so that you can see how many entity were generated, parts are generated, right? And then not only this one, we can see. Let's click the another statistics. So we don't have any information here because we didn't specify the frequencies, that right? And then here again, number of the inspection, number Cs. So since we have a resource called inspection and the workstation, so that's why we have actually utilization info of this one. Right? Utilization, record value, right? Utilization of these two resources, and then seems like this one actually have a higher utilization. So if we increase the number of workstations, basically we can also reduce the utilization value as well, right? But in reality, you need to check the price or cost to increase number of workstations, right? Or the another cost of the another operational cost of this workstation as well, right? In reality. Okay, and what else? We have a number of good parts, right? Here is a user specified statistics. So record module, right? We counter the actually the entities or number of parts, right? Number of good parts is like this, and number of inspected part is like this, and then number of scrap part is like this. So we can check the percentage, by the way. So about 9% out of the inspection part are scrapped. Interesting. It was what was it? It was a 14 out of these parts, right? Out of the inspected part, right? Was it? So interesting. This one is 14, right? But the number of scrap part out of the inspected part is only 9%, because it's a statistic. Actually, since we are using the statistic information and the probability value, so the value may not be exactly the same. If we run the simulation for longer time, and then basically we can have a more reliable or more similar value, I guess. All right, so let's stop this one. And then going back to the arena model, right? And then stop this one, because currently I want to change the model a little bit more, because simulation time unit is hours, and 2.77 means 10,000 seconds, I guess. So you can, if you go to run setup, even you can change the base time unit like a second. Okay, and then here's the same. If you click OK, and then if you run it, and then you can see the time unit in second here. You got it? And let's see the result again. Results can vary because we are using statistical distribution as well as a probability value. So let's see the result in this time. So if I just go to the counter as well, and then but still quite similar, right? Due to the random seed, and then right. So if you make only single replication, usually it gives us the same result. By the way, because the random numbers generated by the generate sequence, random number generation sequence is determined by the seed number. And however, in this case, since we only have one replication, right? Only one replication, so that's why there is no huge variability between the different simulation run here. Anyway, please remember the contents addressed in my lecture. All right. Okay. So what else? What else? Oh yes. Let's go to the change the picture. Change the picture. So how can we change it? So go to the data definition. Right, there is the entity, and then there is entity picture here, right? So let's change the picture. Blue ball is good. Blue ball is good. Okay, and save it. And now we have blue ball. See, right, now we have blue ball. Okay, nope. Yeah, let's stop it. Okay, so yeah, that's a solution. This is a solution of the model exercise for the 6. However, if you want to change the also picture for the scrap part and then go part, yes, you can do that. Let's put the assign module here. No, you don't have to change this one. So let's change the assign module here and there. Yeah, this is out of scope of the problem, but let's do that for fun, right? So if you go to the assign module here, right? And then you can put the assign module here, right? If you don't like it, you can put this assign module here or here. So I'm sorry, let me just put this module here. And then go to home and make a connection here and there. And what? Picture assignment, entity, picture assignment, assign. Yes, this is a name. And I'm sorry. And here attribute, here is called entity picture. So let's say entity picture name, what's that? Green ball, yeah, no, red ball, inspected part, no. So green, blue, yellow ball, right? So yellow ball, we just change the color of the part. So once inspected part will be yellow, and then another one. Let me put, yeah, because there is no delay, so it's kind of hard to see the actually the color of the entity here. But anyway, let me put another assign module here, and then make a connection between the module. And let's click this one. Oh, part picture assign to. And click add. Entity attribute name is what? Picture. Entity dot picture, right? That's the name of the picture of the entity. And red ball, right? So because this is a picture for what? Scrapped part, which means the part having an issue. All right, and then let's slow down the speed of the simulation and save it again, and then run it. So blue mode is here, and then going through the good part. Okay. What about next one? Okay, next one is good as well. No inspection. And third one is no inspection. And fourth one is also no inspection. It's hard to see observed something here. All right. What of fifth? Let me increase speed a little bit. 7, 8, 9, 10. All right. What's happening here? All right. Oh, it was too fast, isn't it? I just saw something here, but it's too fast. Yeah, since the inspection time is too fast, so that's why it's hard to see something here. Only one inspection. So we have about 44 inspected parts. So we just saw the yellow one here, right? I just saw the yellow one. Then after the wave time, and then there is a red item really quick. So anyway, yes, that's how we change the entity picture. Okay, so you can use sign module. Also, you can also use this create module, entity data module. Okay, to change the uh, yes, we just saw the yellow one, right? To change the picture of the entity, right? Let me stop it. So this is exercise 4-6. Yeah, you can actually, you don't have to put these two, right, to complete the assignment. Thank you.